Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbook. Okay, so as you can see in this long wall of text, this is most likely going to be an exam question. Alright, so we got a ski lift, we've got the distance horizontally, so that's the run, which is 2 kilometers. The elevation, the rise, is 300 meters. The spacing between the chairs is 30 meters apart, or the lift chairs rather. And each of these can operate at 20 kilometers per hour. So the cable that is being pulled, and the load for the chair is 260 kilograms. We want to find the power that is required to operate the lift at a steady speed. Keyword, steady speed. And then we want to find the power needed to accelerate the ski lift from rest to 6 seconds. Okay. Step 1, draw your free body diagram. This will help you visualize the problem. So we got a rise, and then we got a run of 2,000 meters. So vertically 300 meters, and then a run horizontally 2,000 meters. And then the spacing between each ski lift is 30 meters. Okay, step 2, list all the given values and find the unknown. So we want to find the power of the operation, or the lift operation. So we want to find the power required to operate the lift at a steady speed. And then we want to find the total power required to operate it when it is accelerated. So they give us the distance, they give us the height, they give us the mass of the lift or chair, they give us the spacing, 30 meters, they give us the velocity of the cable, which is 20 kilometers per hour, and the total change in time for the acceleration. So that's probably part B. Everything else is part A. Okay. Step 3, find the power of operating lift formula. So W dot is equal to the work divided by time. So that is the power in this instance. Step 4, find the total work of the lift operating formula. So we just want to find the work. So that's the total mass multiplied by gravity multiplied by the change in elevation. So we know the change in elevation, it is 300 meters at the top and 0 at the bottom. For the mass, step 5, we want to find the total mass formula. So that is total chairs multiplied by the mass of the lift, or a single chair. Step 6, find the total chairs. So that's the load. So number of chairs, so that's 2,000 meters divided by 30 meters in spacing. That'll give us 66.667. Alternatively, we're just going to use this in our calculator for the ratio. Instead of rounding the decimals, we'll just directly put this into our calculator. Step 7, find the total mass of the chairs. So have this ratio multiplied by 260 kilograms. We'll get 17,333.3. Okay, kilograms. Step 8, find the total work. So just plug and play. Plug everything that we found. Make sure we put the conversion factor. So we've got our total mass, we've got gravity, and then the change of elevation. So that will give us 51,012 kilojoules of work. Step 9, find the change in time. So that is distance over speed. So remember your physics, your DTS triangle. Except for S, it's V in this case, but velocity and speed are the same. Okay, step 10, plug and play. So 2 kilometers divided by 20 kilometers per hour. That is 0.1 hours, which is 360 seconds. So our delta little t is 360 seconds. Step 11, find the power of the operating lift. So in step 8 we found the work, and in step 10 we found the change in time. So we can go back. So here's the work, and here's the time. Okay, so it's just work divided by the change in time. So 51,012 kilojoules divided by 360 seconds. That gives you 141.7 kilojoules per second. Kilowatts to kilojoules per second is a 1-to-1 ratio. So you've got 141.7 kilowatts. And that is the power at a steady speed required to operate the lift for part A, or part 1. Okay, part B, or part 2. So we want to find the total power formula. So this is the total power required to accelerate from 0 to 6 seconds. So we got the power of acceleration and the power of operation at 6 seconds. Step 13, find the formula for the power acceleration. So it's half mass multiplied by the change in velocity divided by time. So the change in velocity divided by time, that's actually acceleration. And the mass is just the total mass, and we half it. Okay, step 14, convert kilometers per hour to meters per second. So 20 kilometers per hour, that's given in the question, multiplied by your conversion factor, 1 meters per second, divided by 3.6 kilometers per hour. That will give us 5.556 meters per second. Once again, just use the ratio and multiply by the speed. So that way you don't have to round up your decimal in your calculator, that is. Step 15, we just plug and play, find the power accelerated, or the accelerated power. So here's our formula. We just plug in our mass, we plug in our change in velocity, and then divide by time. Make sure you have your conversion factor to get it into kilowatts. Okay, so that'll give you 44.582 kilowatts. Step 16, we want to find the power for the lift operation at 6 seconds accelerated. Once again, total mass multiplied by gravity multiplied by the height of acceleration divided by the time, which is 6 seconds. So the change in time. So 17, find the height of acceleration formula. So height is equal to half acceleration multiplied by time squared. In this case, our little t is equal to the big T. Sine alpha. So alpha is the angle. In this case, it is just rise over run. Okay, so we're going to continue below. Step 18. So here's the formula again. So for the acceleration, it's just the change in velocity divided by change in time. So this is found in step 15. We can backtrack just a little bit. Right over here is our velocity. And as you can see, it's over here as well. Okay. So that's where we initially found it. That's why I put it there. And then rise over run for our alpha angle. So that's just 300 meters divided by 2,000 meters. Okay, plug this into your graphic calculator. And you will get 2.4906 meters. Okay. Step 19. We can now find the power for the lift operation accelerated at 6 seconds. So the total mass, once again, it's just your ratio for your 2,000 meters in distance, and then divide by the spacing. So that'll give you the total amount of chairs or the load, and then multiply that for the mass of the lifts, for one single lift, that is. Then multiply by your gravity, 9.81 meters per second squared, multiplied by your height, 2.4906 meters, divided by 6 seconds. And that will give you 70.58 kilowatts of power for the lift operation accelerated to 6 seconds or at 6 seconds. Okay, so now you just combine the two for the total power, combine the power for acceleration, and combine the power for lift operation at 6 seconds. So at step 15 is where we found our accelerated power right over here, which is 44.582 kilowatts. And then previously, step 19 is the 70.58 kilowatts. You add them together, you will get 115.162 kilowatts. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly recommend that you save this video onto your PC just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. So click on your icon in your taskbar. If it's not on your taskbar, go into your Windows search, type in snipping tool, open the program. Click on video option once you have it open. Then click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Then hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square and snipping tool to stop recording, and then save your video. Alright, so thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made-up question. If you got questions, comments, or if you found a mistake in this video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Good luck for your exams. Until next time, see ya.